What's up, everybody? Welcome back. Today, I want to try to parse time zone info. Specifically, I want to be able to take my little utility we wrote yesterday, zig run main, that prints the current date, off by 1 on days, because day 0 is the first day of the month is not day 0. But anyways, it prints this thing, and it prints the time, but only in UTC time. And the way we do this is we get the time, the number of seconds since the Unix epoch from the system, and we do a little bit of math to basically account for leap years to figure out what the date is relative to January 1st, 1970. And then we do a little bit of like modulo math to figure out how those seconds map into hours, minutes, and seconds. And that seems okay, but Unix timestamp is defined as 1970 number of seconds since 1970 January 1st midnight in UTC, which is like, I think it's universal coordinated universal time. So I am not there, right? So we're seeing that it's like 8:42. It is 12:42 here because we are 8 hours behind when we are in Pacific Standard Time. And so I guess what I want to know is how the heck does that happen, right? So I did take a little peek yesterday at the date source code, right? So when I run date, we do in fact see right now, and so I want to know where the hell did they get that info from? And I scrolled through here a little bit, and I saw something about time zone. I just like grep for TZ, I think. TZ alloc. Yeah, we see this function call, Mr. TZ alloc, and if we look up what that function is, that is, oopsies, am I crazy? I could have sworn that I saw it. Man, TZ alloc, maybe it's not on my system, but I googled the man page. Maybe I did this. Yeah, so it's in part of the standard library in C, and it defines time zone info. And so you can allocate with a zone flagged by character, takes a time zone name and returns a time zone t object, suitable to use in ctimerz, localtime.rz, and maketimez functions. I don't know what those do. This is about as far as I read. If zone is not a valid time description, or if the object cannot be allocated, this returns a null pointer, blah, blah, blah. And then I assume I didn't actually check this, but I assume that they use this time zone that they get to like do some sort of adjustment. They say that we like local time, no. What other functions do they say? They have ctimerz, make time, ctime. Nope. Okay, let's see if we can figure out what they do with this thing. Parse date time 2. Let's see if we can figure out what they're doing. Is this even their function? Doesn't look like it's defined in this file. Maybe we have to clone core utils. Maybe we have to do a little cloning. Let's take a little beak skis. And once we figure out how they use it, we can kind of figure out what we're supposed to do. What is this thing? Who fucking knows? I also know from like setting up stuff that there's this file etc local time that links to zone info Vancouver. So I'm pretty sure that these two things are related, but I could be wrong. I'm kind of like assuming that for now. Okay. Parse date time. This is all in date or in core utils. Unsigned int, parse date time. Oh, no, parse date time flags. God damn it. Parse date time 2. Really, literally not defined. Is this like a man thing? What is this? Am I crazy? Parse date time 2, right? We don't... Is this like a macro? That's crazy. Okay, but this guy takes the time zone. So... that sounds relevant. Oh, but this is also like when we are giving it... That's kind of probably more for when we're giving them a date to print, which is probably not actually the relevant piece? It's probably show date helper, which is the relevant piece. Show date. Dude, where? Show date. Maybe this. Oh, show date.c. This is promising. Display the date time when, according to the format specified in the format, followed by a new line. And then time zone must be relevant here. Yep, local time RZ. Wait, okay, huge. So this is where this is eventually going. Local time RZ. Maybe one of the first things that we should do is try to use local time. Let's try to figure out what these functions do, and then we can figure out how to like bypass them if we feel like it. So we think that we should be able to do like test C maybe. Int main. We should be able to do something local time RZ time zone. And let's take like a Unix time of now. Unix time now. Instead of doing anything sane, we can just do this. But he wants a pointer to this thing, I guess, and then a time. TM is probably out, right? Struct TM, and then we need a time zone. So, what is it? Struct time zone T is TZ Alec with probably America Vancouver is where I am, right? So probably something like this, or maybe null to indicate use local time is maybe what they said in there. TZ Alec function takes an argument as a time zone name and returns a time zone T to be used in these things. If zone is not a valid time zone description, or if the object cannot be allocated, null pointer may be passed instead of a time zone to refer to the current system time zone. Perfect. Okay, so we get a time zone. We say, can we look at like man local time RZ? What is this? This guy is TZ clock result. Similar to R, but also takes the time zone T argument. Perfect. And then do we get information about like what clock is for? It's also, am I crazy this isn't a pointer? Also, like, this feels like we're missing types. Am I crazy? Oh, here we go. Local time R. No RZ. Well, we gotta, I guess we trust these guys. So we probably have, like, I guess we'll see when we try to compile how this is fucked. Let's just do that. Okay. This guy returned something. This thing should equal 0, I guess. So probably something like this. Something like this. And then we should be able to, I don't know. What is this thing? It would be nice to have Clang here, huh? Clang tools. And then this is probably from time.h. Okay. Where did TZ Alec come from? Time.h. So why do we not have that? That's not good. We're missing some information here. TZ Alec. Header. Where does this come from? This is for, maybe this is only for NetBSD? Am I crazy? No, surely not. Can we actually go into core utils with Clang tools? And maybe then we will be able to jump to definition on their thing, and that'll help us. Show date. I mean, he's mad too, huh? Can we build this thing? Bootstrap. I guess we probably want a Nix environment, with import Nix packages, packages make shell, and then it's like you do something like imports from, like core utils. Surely, right? So, surely something like this? Okay, yes. Then we can bootstrap? No? Okay, well, that's cool. Did I get the shell thing wrong? Nix shell imports from. Um, no, shell Nix, not Nix shell. Can I just look up shell.nix? Or packages make shell, that's what I'm looking for. That's what I'm looking for. Inputs from, not imports from, my bad. My bad. My bad, my bad, my bad. Nice. Bootstrap? Okay, well, get fucked me, I guess. Automake? Autoconf not found. Well, GG. Maybe it's like core utils dot something. Nixos package search. Maybe core utils. Um, am I stupid? This is not what I was trying to click on. I was trying to click on this, maybe? So, like, shouldn't this guy be like, I want wget? No. Maybe I want, like, core utils full. Is this the same thing? Oi, oi, oi. Let's try this. And if not, we might have to get a little bit more crazy. Looks like it's in a custom package. Core TZ data on Arch Linux. Ah, okay. Yeah, I guess maybe we could look at where the zone info is coming from. Yeah. Because we assume that these are related, which we don't actually know. Like, is this coming from some package? TZ data. TZ data. Maybe this is also something on, like, Nix. Yeah, nice. Database of current and historical time zones. And what does this guy... Where does he come from? This looks more like just actual data. Well, he's got C flags. Okay, let's look. Local time RZ. Let's look up this function again and just where the fuck does this come from? Local time R might be defined. Yes. Okay. Local time R is defined in standard library. So there's something there at least. RZ seems to be a BSD thing. Yeah, maybe I'm just confused about where I was looking. Okay, so maybe we just do this. Okay, so he wants a time T timer. So how do I get one of these? Return timer representation. Okay, man, local time R. Do we have that? Yes. Okay, cool. So we have transform date and time to broken down time or ASCII. How do I get one of these time P's? Converts calendar time P to broken down representation. Calendar time P. Do I just make it? What is this guy? Second since epoch. Oh wait, we're chilling. We're chilling. So we have a time T time is equal to this. And then we have time here like this. This guy returns a struct tm star tm. If tm is null, return -1 or something. And then this guy wants null here, surely, right? Maybe we need to pass in something here. I'm not sure. Not sure. Then what is in this thing? Oh. Okay, let's print this. Printf. Let's just look at tm.hour. This is what I'm really interested in. Okay. segmentation fault. Cool. Cool. I don't really know why this. Okay, let's look at the docs again. Man, local time R. Wait, what does it mean? R and local time underscore R. Local time R, but stores the data in the user supplied struct. Oh, so we just don't want to do this. We just want local time. There we go. Okay, 12. That's the correct answer. It is almost 1 o'clock here, so 12 is the right hours. And I guess now we try to figure out what the fuck these guys are doing, right? Which may or may not be the same thing that the date utility is doing. Who knows? Because we couldn't find that time zone shit. But if we do strace test, we do see them opening local time, which is a good clue. Good clue. Does etc local time have a man page? Well, that's not what I was trying to do. Okay. Somewhere the other day I found a definition of the local time file format. But I think that was through me looking at the time zone stuff. I'm a little confused still about where like local time RZ Linux comes from. Maybe let's just double check core utils here and make sure that's not hidden behind some sort of like if def. So that would have been in show date, right? So I guess we kind of want to look for like local time RZ in this whole thing and see if they're defining it if it doesn't exist or something. No, it doesn't look like it. It looks like it's just kind of round. Core utils are super bare bones. Most of this will exist in LVC if I'm not mistaken. Okay. Okay. Man5 TZ file gives you that format. That nice. Okay. Where does this come from? This is what I was looking for. But how do we tie this back is the question. I guess we just kind of run it and see what happens. So we have proof that if we want to get the local time, it pulls that from etc local time. We have like a proof at least that he's trying to open that thing. So can we try to parse that thing now is the question. Maybe we can look at it and see if it says anything interesting. These files use the format described in this guy. Perfect. So we can look at this if we want. Each file is a sequence of 8-bit bytes. In a file, a binary integer is represented by a sequence of 1 or more bytes in network order. Okay. So, sure. With all bits significant, a signed binary integer is represented using a 2's complement, and a boolean is represented by a 1-byte binary integer, the 0 or 1. Okay. For it begins with a 44-byte header containing the following fields. Okay. Let's just see if we can parse the header then. Maybe. I don't know, man. I don't know. Am I in the wrong folder? I think I am. Can we figure this thing out? So, we have a TZ header, probably, right? And we are expecting a version as U8. 15 bytes containing zeros for future use, so 15 bytes of padding. We also forgot there is TZ if as the magic. Then we have 6 4-byte values, right? So we have Uh, tis Is this 4-byte integers? Are these signed or unsigned? Unclear to me. What do they say? And so they have uh a binary integer is represented as a sequence of one or more bytes with all bits significant. A signed binary. So if they're not saying signed, I assume that means unsigned. So we have is utisdent. We have ttisdent. We have leap count, time count, second count, car count. Okay, so these are all 6 U32s. Okay. Who knows what these are yet, but we'll figure it out. Okay, and then does that line up with the size of the header? 44 bytes. So this is 1, 2, 3, 4, 5, 6 times 4 is 24 plus 16 is 40. So we're missing. Oh, but plus the 4 bytes of identifier. Cool. Cool. Okay, so then we need some sort of like parse from a stud IO reader, right? And this guy is going to basically just get all of those things. So he is going to be like, take 4, and if this is not the same as thank Zod it's Friday, then we return invalid magic. Right? Did I forget a bracket here? I did. Then we parse out the version. So this is take byte. We have big endian. A bunch of things. Well, we have to drop, discard all of however many bytes are left here, which is 15. We have to then go, I think now we can just kind of hit return here and say version is version. And then for all of these guys, they're just in order reading of big endian U32s is what we think. Try R, take int U32 big. Boom, 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 boom. All right. And let's try to open this thing and see what happens. Local time file is open file absolute of etc local time. Okay, with I don't give an absolute flying fuck arguments. We probably have to close this thing later. We probably want to then try to parse the header of this thing. So we need like local time reader buff. Can we just do this? Read tz. And then we can name things accordingly. So reader buff, give them some space. We do local time f reader with reader buff. And then this is file reader, and then we have our R is file reader interface, bang, bang, boom. And then we can do try parse with R and see what happens. Let's print that thing. And let's see what's in it. Read tz. And then can we, if true, return, just to like get us where we want to be. All right. He is mad because we have an invalid magic. So we're already fucked. Hex dump etc local time. Hex dump dash C. Give me. Am I stupid? We open this thing. The first 4 bytes are tzif. Interesting. Oh, not equal. You do have to do the thing. Okay. So we got version 50, which is that consistent with what they said. It's an ASCII null 2, 3, or 4. Okay. So we want to print. Let's do a little bit of this. I don't know. So this guy's going to format self as a TZ header. He's going to take in our std IO writer. And let's just get a little creative here. So we're going to say the version is printed as a character. Like this. And then we just gotta do these as well. So this is gonna be, there's a macro here. Try W print. This thing is a number, paste, but with the word self in front. And then I think I fucked the macro up a little bit. Yeah. I did like a find bracket, which was no good. So I think if I do find this, it's fine. Easy. Easy. I'm sorry, what the fuck was that? Oh, yeah, macros in Vim are just the sequence in a buffer. It's the same as yanking. So if you do like QQ, down, 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 and then you do like quote Q paste, you see the JJJ, and then you can like add a couple more J's in it, and then do like yank back into the Q buffer, and then when you run the macro, it jumps by that many now. You can literally just edit them on the fly. Isn't that kind of fun? Isn't that kind of fun? Okay, somebody's mad here. I don't know why, to be honest. Something is not syntax styling correctly, but like whatever. Let's print this format style. Am I stupid? What's he mad about? Expected type found const. Oh, I see. This can be constant. There we go. Okay, version 2 is in here. So what do the rest of these things mean? Number of UT/local indicators stored in the file. UT is universal time. So there are 5 time indicators. Number of wall indicators, 5. Number of leap seconds were in the file, 0. Number of transition times, 190. Wait, we forgot char count. Oops. Okay. I'm sure this stuff will be relevant eventually. So this 4-byte integer values sorted in ascending order. These values are written in network byte order. Okay, the above header is followed by the following fields, whose lengths depend on the contents of the header. So for however many of these things we have, we are going to read that many 4-byte entries, I assume. Okay, so we kind of want this thing to have some sort of like, this thing is like probably like an iterator of sorts, right? Like the reader of this thing is going to kind of like, I guess we're going to have a reader. And we kind of want like stages of this thing, right? So we probably want like every time we step this thing, it returns the next stage. Not sure yet. Not sure yet. And ideally, if we want to like give back pieces that can be read. Let's just do it as a function first. It'll be easy that way. We'll figure out nice interfaces for it later if we care. So we can go for tz dot, what was it? These things are going to be in order, right? Time count. So uh so for each of these, we're gonna have something. So it's like read int u32 big, and this is gonna be I don't know. We're gonna print a tzh. This is transition time, at which rules for computing local time change. I don't know what this means, but we'll take a peek at what they are, and maybe we'll understand as we go. Then we get these guys, which say different types of local time types described in the file is associated with the time period starting with the same index transition time and continuing up to but not including the next transition time. These values serve as indices into the next field. What? Oh, okay. So these are kind of locked together with transition times. So at transition time, X, we start using this index. Right? So we should be able to be like, take byte. I think it's actually take int, not read int. So this is transition index. Okay. So there are 20 transition times sorted in ascending order. So to some extent, this makes sense. However, it like drops, and it said they're supposed to be in ascending order. So I'm not sure what's going on there. That doesn't seem right to me. It does not seem right. 4 byte signed integer values. Oh, signed. Okay. I don't know what these mean yet. They seem pretty fucking crazy, but like they are sorted. So we'll see. What is WM? Window manager. Okay. So let's try to maybe look at what these transition indexes are. Each defined as follows. Each structure is written as a 4-byte signed integer value for this in network byte order, followed by 1-byte boolean for TD is dust, and 1-byte value for TT designates. In each structure, this gives the number of seconds to be added to the UT, the universal time. This tells us whether is dist should be set by local time, and TT designates serves as an index into the array of time zone abbreviation bytes that follow the TT info entries in the file. Jesus Christ. Okay. Okay. Oh, so maybe this is like daylight savings? Oh, is this a list of like all of the times daylight savings will occur? Because we're gonna flip between 2 different modes, 2 and 1, and these are happening like, are these like half a year apart? Like, what am I looking for? Kcalc. Like this minus this. Did I get it? No, fuck. Okay, this, this minus this. Over 60, over 60. So that's hours over 24. 237 days, which is not half a year? Who fucking knows, dude? Am I doing this right? Hold on. Let me triple check this. This minus which one did I pick? 808, this one. Divided by 60, divided by 60, divided by 24. 126 days? When are like daylight savings times? Can we look at like what this is even? We have like a date command for this. invalid date. Man date. How do I like give him a timestamp? There's a way to do this. It's date equals this. March 8th? I think that sounds kind of daylight savings-y, to be honest. And this is November 2? When is like daylight savings 2014? Daylight savings Vancouver 2014. March 9 and November 2? This seems pretty daylight savings-y. This seems daylight savings-y. So this is basically telling us that we swap time zones every once in a while. So we should see, if we keep going, that the next sections are going to be basically the -7 and -8 for PDT and PST. That's what I'm going to assume here. So let's make one of these like TT info. I don't know how this should be abbreviated, like how this should be cased, because I don't know what these stand for. But I'm gonna go TT as one thing because it has TT underscore here. So we're gonna have like a function parse, right? And this is gonna return one of me. And we're assuming that we take a TT UT off is our read or take int of I32 big. Then we're gonna say take byte for the next two things. Is dest. Oh, is DST stand for daylight savings time? Maybe? Time. Yeah, it's a time. A time, of course. Dizigidix is equal to another take byte. And then we want these guys to live in here. So this is I32. This is U8. And this is U8. Okay. So then we should be able to say, how many of these are there? Type count entries. So for 0 to TZH type count, we do a little TT info is TT info parse R. Okay. And then we try to print that thing. All right. Yeah, we do need to say that this is a struct, huh? That's a pretty good point. Okay. So we have 0, 1, 2, 3, 4 of these things. We have alternating between index 1 and 2 a lot, right? So is daylight savings time 0 and 1 is flipping, which is nice. UT offset, I assume that these represent -7 and -8, I would guess, right? So if this is 25,200 over 60, that's 7 hours. And this is gotta be 8 hours, right? Yeah. So we're at -7 and -8, which are the two time zones that I live in, which is pretty sick. And so that means that this one is that our guess of what is DST means is probably pretty correct. By guess, I think they actually told us what it means, but I didn't read that part. So, you know. Tells us whether or not this should be set. Okay. Serves an index into the array of time zone abbreviation bytes that follow the TT entries in the file. Oh, so this is there's going to be like postfixes for each of these probably, right? So they're saying like this, if I have like -00, this is going to say like -07 null byte or something, right? That's 4 characters because this is, yeah. So if we look at the characters section, we have like a car count in here, I think, right? Which is the next thing. So if we go, we just try to print this, right? Oopsies. So we just tried to like take TZH car count, I think is how many it says. And here we're expecting to see a bunch of like time zone postfixes. Ooh. Yep, so I have PDT, PST. These are two other time zones I've never heard of. But PDT and PST are things that I... Local mean time. Oh, okay, so it's local mean time, PDT, PST. What is PWT time? Pacific Winter Time? No. Palu time, which is the name of UTC plus 9. I don't know why that would be in my local time. Are you a C dash open bracket enjoyer, or how do you exit enjoyer? I slap escape. And then was PPPT. PPT time. No, well, who knows? But I mean, these two are equivalent. Interesting. And it's also interesting that I don't see those ever. Oh, we do index them here. Oh, so I wonder if in early days we were on like the wrong fucking time zones in Vancouver. What year would this have been? So this is 0, 1, 2, 3. 0, 1, 2, 0, 1, 2, 3. So it's like here. Date equals this. Invalid date. Unix epoch time converter. It's not a fucking invalid date. $1942. What's this one? 1945. At prefix required. Oh, my bad. Ooh, okay. So back then we're in fucking PWT. So I guess if we look at like history of Vancouver, BC time zones, we'll probably find that we were in time zone. This isn't okay. Yeah, we must have like moved at some point. I don't know how to like see that in a list somewhere. So interesting. So that's why this file needs more than just like the two standard ones, is because we've had like historical offsets. And then I guess these are sorted by time or something. So that's probably why we see this one earlier, is because at some point we were -6, and then sometimes we were -9, but usually we're -7 and 8. What fun. What fun. Okay, so this is actually not that bad so far. What's next? Leap count. Pairs of 4-byte values written in network byte order. The first value of each pair gives the non-negative time as returned by time at which leap second occurs, or at which the leap second table expires. The second is assigned integer, specifying the correction, which is the total number of leap seconds to be applied during the time period starting at a given time. The pairs of values are sorted strictly in ascending order by time. Each pair denotes 1 leap second, either positive or negative, except that it has the last pair. So when we were looking at this yesterday, aren't leap seconds like not accounted for by Unix epoch? Like, I thought that my understanding from what we were looking at yesterday was that we don't have to think about leap seconds. Which might be kind of corroborated by the fact that there is no leap counts in here. Which is great. So let's just do this. I guess it's like if this is not equal to 0, return error unimplemented. But we don't have to worry about that because we don't have it. Easy peasy. Easy fix. Okay, so then we are looking at wall indicators stored as 1-byte boolean. They tell whether the transition times associated with the local time types were specified as standard or local wall time. Oh my god. Okay, the transition times. We have it, so is stood TT is stood count. Standard is standard count. So where do those tie in? And then we have this tells us whether the transition times associated with local time types were specified as UT or local time. I'm confused. So how many of these things do we have? 5. 5. And then do these get indexed by one of the other things we've looked at, maybe? Standard wall indicators, each stored as a 1-byte boolean. They tell whether the transition times associated with local time types were specified as standard or lol type. The standard wall and UT local indicators were designed for transforming a TISIFS file transition times into transitions, appropriate for another time zone, specified via a proleptic time zone string that lacks rules. Holy shit. Okay, for example, when time zone is equal to EET minus 2 EEST, and there's no TZIF file to EEST, the idea was to adapt the transition times from a TZ file with well-known POSIX rules that is present only for this purpose, and is a copy of the Europe Brussels, a file with a different UT offset. POSIX does not specify the details of this transformational behavior. The default rules are installation dependent, and no implementation is known to support this feature for timestamps past 2037. So users desiring Greek time should instead say that they're from fucking Athens. For a better historical oh my lord. Falling back on T is equals EET minus 2 EEST M3.5.0/3 M10.5.0/4. What? Okay. That's crazy. Okay, hold on. Let me see if I understand this again. So this is transition times, right? So the time counts. So this thing has, time indicate. Oh no, wait, hold on. Times. So there's like a list of times that are when we transition. Each one of those has an associated index into the TT info of where it is going. All of that makes sense. We then have some like character stuff, which is basically like if you're trying to display the time zone, you like index into this according to what you had in here, right? So he says, in here, this offset is used to index into this string of characters, and then that thing is null terminated, and that's how you find your like PDT PST string. Perfect. Then we have leap second stuff, which we are not handling because we have 0 leap seconds in our database, and I don't want to think about it, and even if I did want to think about it, I would give up or something. Then we have 5 of these standard wall indicators. Each is 1 byte. They're literally booleans, and they tell whether the transition times associated with the local time types are specified in local or wall clock time. And this says whether the transition time with local time types were specified as UT or local time. So this is where I'm confused, right? Like, are these associated with the TT infos? If they are, because there's 5, right? 5 of these. If they are, why aren't they just part of this structure, right? And also, how does this relate to any of this shit? The standard wall and UT indicators were designed for transforming. So they're claiming that they're related to like adjusting according to some other time, right? So they're trying to say, hey, I'm related to this thing, but I don't understand where, I mean, maybe this is relevant in some way. The local time function normally uses the first TT info structure in the file if either time count is 0 or the time argument is less than the first transition. Oh, okay, sure. So this is unrelated to that stuff. We might have to come back to this. I am pretty lost at these, but at the very least, we have to parse them. So can we say tz, like r discard all tz that with the number of bytes for is standard count, and TT is UT count. We might come back to this. I really do not understand these. Okay. Then we are in version 2, right? I believe that's what we see in our header. So we need to keep reading. Right? Version 2. So is it version 3? Does version 3 include version 2, or is version 2 separate? We'll see. Identical in format except that the 8 bytes are used for each transition time or leap second time. After the second header of data comes a new line enclosed string in the style of the contents of the proleptic time zone for use in handling instance after the last transition time stored in the file. Ah, okay. So you might say something like this. You might use some other file or something to keep going. The transition's local time type must specify a daylight saving time abbreviated west. Okay. That is 1 hour east of UT. I don't understand that part. Also, if there is at least one transition of time type zeros, blah, blah, blah. Okay. Well, we'll figure that part out maybe later. Because, like, here's the thing, is that the basic version of this makes a lot of sense, right? Like, the information that we have right now gives us, like, the offsets. So there's a lot of, like, other weird shit in here that isn't just, like, take the UTC time and add -8. But I don't really understand, like, what that is. You know what I mean? Check the RFC. TZ POSIX string is a string suitable for the TZ variable defined here, with the exception that the string may not begin with a colon. The string is not terminated by ASCII null. Here's an example. In this case, the string is interpreted as a time zone that is normally 5 hours behind UTC. So where the fuck is that coming from? There's a 5 here, and 4 hours behind UTC during DST. Oh, so they're defining a time zone string plus its offset, probably. Then this tells us probably like when these things apply or something. This 2 o'clock sounds like it's right. So there's a comma separated thing, right? So what the fuck? This RFC is about DHCP. Oh, Jesus Christ. What is the, like, M3? Can we go over here? Can we Google this? Oh, do I have to pay the money? PDF. Fuck. Here we go. We just click this one right under it. And then it was section 8.3 or something? I guess we're kind of on parsing. This is taking forever to load. Oopsies. This is what you want? Oh, here we go. We fucking got here. So it's section 8.3, right? TZ. Okay, start slash time, end slash time. So what does the start mean? Like, why are there M's in their examples? Oh, M. Ah. 10th day of week N of month M of the year. Crazy. Crazy. Okay. Sure. So, all of that to say that, like, at the end of all of this, they're like, okay, we ran out of, like, answers. Here we'll just literally give you a fucking magic time zone string at the end. But then how does that relate to the, like, standard wall indicators? Can we read this like RFC? I'm missing something here. I still don't understand this. Number of transition times. Specify number of standard wall indicators. Okay, so we want to look. Oh! Wait, okay, this makes more sense. Must either be 0 or equal to type count. Okay, so why do they have separate things? Because you might not have them. You might omit them entirely. Okay. Okay, so that makes sense. So our, like, parsed time thing, what does it look like? We probably are going to allocate here. Fuck it. And we are going to return the header, right? We are going to, actually, maybe we don't even need the header, to be honest. We are going to have, like, we're going to have infos, maybe? Or, like, zones or something, maybe we call it, which is going to be an array of a new thing. It's, like, very similar to struct TT info, but, like, not really, right? This is going to be, its own thing. So here, like, we have UT offs. Is daylight savings is a bool, probably. And then here we're going to have the, like, TZ string. Right? We're going to have one of these. We're going to have a, like, is stood, right, for these two other things, and is UT, right? Is that what they were called? Is UT and is stood. You're cool. We are going to have in this thing a list of times. And this is going to be a list of I64s, right? Because version 2 supported 8-byte or 8-byte values, right? So I think that makes sense. And then what? So you have times, transitions. Oh, these are the transition times. And these, we want to store these kind of a more convenient way to store these is like time and zone, right? That's kind of how I feel like I want to store this stuff. Okay. Then what? Is that everything we have so far? I think it is. So this guy returns our TZ info, and in order to like figure out how large this array is, if we want to one-shot this array, we can't really because we don't know how much is going to be in the version 1 and version 2 sections. But we can like kind of make a guess. Stood array list of, I guess we should have these as structure, like real types, so that we can reference them later down below. Zone is one of these guys. Okay. Chill. We're so chill. And we can do, hit me with an array list of time. And here we can do like init capacity with the time count, right? It's going to be at least this many. At least. Then we have zones of, what is it? Type count. Okay. Then why the fuck, by the way, is my like indexer not working? It's kind of annoying. So for each of these times, we are going to push append with time is val and zone is maybe we'll say like invalid. Or something. Maybe we'll do this and we'll let him flag it manually. We'll just say zone by default is equal to this. Okay. Actually it's usize, so it's like this, right? Append bounded. Yeah, I guess you're right. We do kind of know in this scenario that we do. You're right. We do know this. Let's do stud math max int of usize or something here. Okay. Then for these, we should know that we have times items at I dot zone is equal to val. And here we can kind of say that this is a U8 here, to be honest. Okay. Cool. Then we have zones here, so we're doing like zones append bounded. I guess it's technically not, I guess it is actually count unreachable because we're only iterating that many times. Sick. Okay. So this guy again, we have kind of like some unknowns at the end here. These might want to be like optional bools. I'm not sure if there's like null behavior on these things, so let's do this for now. And I guess technically you could actually do something that's more like zone is like union of like, you're kind of like duplicating the optional info. You know what I mean? So you might want to do like has stood, you know? and has UT, so that you can kind of like not duplicate that information over and over again here. Or I guess you kind of I guess you just do this, right? Because these, like, you only want to store this stuff if it's available. And you could even do like packed, like whatever, it doesn't matter. Doesn't matter. For now, I'm just gonna do this because I don't want to think too hard about it. But now we should be able to be like, hit me with the UT offs. Or whatever the fuck it is. Okay. So what else do we have in here? We have is dest is if this is non-zero, and we are trying to get the string out of this thing. So we haven't parsed the strings yet, which is interesting. So I think what we do, it would be nice to be able to just like shove this thing right in here, right? So we kind of want to, these are going to be empty for now, and we have to like kind of like come back and fix them, right? And what you really want here is like a lookup. Something that's like for each string index, offset index, which guys do we want to go through? No, what we do instead actually is we duplicate the whole string and we just rip this again. Fuck it, that's easier. So we kind of have like this, right? We have this like take the character list. And we need to make sure these live on the output allocator, because these are kind of in the buffer where they will be discarded later. So I think we want to dupe this shit. Right? And what we can do is we can go like 4 zones. We look at you kind of want some sort of like intermediate value in here, which is kind of interesting. You kind of want like you want like intermediate zones. What if we just didn't do it like this? What if we just do this? Yeah, what if we just store it the way that it comes in? That will just make our lives easier. That will make our lives easier. However much it would be nice to have something slightly different, because you can just expose this stuff as functions, then it's fine, right? Okay. So here we can do this. DESIG. Jesus Christ. Okay. So then we don't have to discard these anymore. We go like 4 is stood count. We look at zones, items, I. And we say is stood is equal to r take byte is not equal to 0. And we do the same thing for is UT. Okay, cool. And then we should be able to return this thing now. We can just kind of skip version 2 for now. I think it's not really super relevant yet. So we have times. We have zones. And then we have TZ-sters. Okay. So we should be able to say that like TZ info is this. Time is not defined because it's TZ info time. Temp here. Read TZ needs an allocator now. Alloc is stood. Heap. Fixed. Buffer. Allocator. Init with alloc buff. We put an alloc buff on the stack. 1 meg. Fuck it. Fuck it. We call this FBA. We call FBA allocator here. He is mad because init capacity needs allocator in here. Okay. No field name UT offs. What is it called? TT info UT off singular. Times items is like, I want a time. Oh. Yeah, this needs to be an array here. So true. Okay. Cool. So we have this stuff parsed out. Wonderful. And now we can try to do something with that. So when we, I guess when we get our time, like, do we have to do anything other than like, hold on. Let's fix this formatting a little bit. So let's not do this if true return anymore. Let's not print this time zone info. Let's just discard it for a second. Okay. So I think what we want to do is when we get the local time, I think we just add the time zone offset, right? So we like, we need to find which zone we're in, right? So is this time, this has to be like the input Unix time, I would assume, like the epoch from in UTC, I would assume. Can we check that? Right, so if I like look at this, Unix epoch, Unix epoch converter, like this is 3 a.m. my time zone, which is when this would occur. This GMT, right? So this is a UTC time for these transitions. So we find the transition for which this occur. We need to like find which segment we're in, I guess, right? So here we do some sort of like match zone for time, right? Where this is going to be a Unix timestamp, and he is going to return a zone pointer, probably, right? And here we're going to be like, for, we can do like a boundary search. Okay, I want to fix my fucking indexer. This is really bothering me. ZLS Zig. Does ZLS need like a build.zig for this to work? No, the colors are all different now, so it's happy now. I don't know what the fuck is smoking before. So there's some sort of like lower bound. Find me the first thing that is not larger than this number or something. So we have type of time. We're looking at self times. And we have the context. Maybe the context is our time. I'm not sure. And the compare function takes in the context and the t that we're looking at. Yeah, so we have to use our thing. And then we have our compare function here. So we have an f, which takes in this stuff. So this is going to take in our I64. This is going to take in our time, right? So val item or something. And we are returning if val is related to item time in here, right? Time item or transition, I guess. And can we print? I guess we return the transition. Well, let's do this. Transition at this. And then I guess we should say transition this for time, whatever time we put in. Just to make sure. And then we return the zone for the zone. And then we should be able to be like, hit me with the zone for my time. So we should be able to be like, tz info zone for time of time sec. Right? And then we should be able to just apply that. Right? So we should be able to take that time u and add zone info offset. And then I think that should kind of just work its way everywhere. I think that should just do the right thing. usize do not support field access. Oh, this gives me the transition index, probably. Probably. Then we return a pointer to this thing, I guess is what we wanted. Incompatible types. He's fucking mad because we already applied that, you dummy. So this thinks we are January 27th, correct, at 3:01:14, which is wrong. It is 2:01:14. So we were probably off by 1. Is the transition has to be where it's going to. We see 2964. This is 77. This is 76. So I think we need to add. We want to add one. We need to double check what lower bound does. Lower bound returns the index of the first element in items that is greater than or equal to context as determined by a compare function. Which is what I thought I wanted. If no such element exists, returns items len. Do I have the order of these wrong? Can we look for an example? Compare U32. So he does order with context then item, which I believe is what we did, right? Val then item. Oh, first item that is greater than or equal to. We want the last item that is less than. So we subtract 1. Nice. So now we have this time for this, and then there's probably some like special case handling, right? So there's like fix me transition equals 0. What the fuck do we do? Right, there's probably something here. Which I think that they said you use the zone 0. I believe. So it's like, if transition is 0, use zone 0, if I recall correctly. Something like that. But look at that. We got our local time. Easy fucking peasy. How hard could it be? What could we possibly be missing? What about upper bound? I think that those upper bound is like the first element that's greater, and the lower bound is the first that's less greater than or equal. I think the difference between upper and lower bound, it sounds like they would do different things related to the like greater or less than, but it's kind of more like if you have 1, 2, 4, 4, 4, 4, 7, and you're searching for like 4. I believe like lower bound gives you this and upper bound gives you this, or maybe this. I can't remember which one. But it's more about like how you deal with like multiple of the same item, instead of like which side. It's not like this or this. You know what I mean? Which is what I want. I want like this guy, or maybe I want this guy. You know what I mean, though. Something like that. There's probably some like UT edge cases, right? But we'll like our edge cases like will be wrong for a second at the daylight savings times. Like who fucking cares? You know, kind of. Unsure, like minorly confident about equals behavior. We could be wrong at the boundaries for 1 second. Whatever, man. Smile. You know, like I don't give a fuck. I don't give a fuck. All right. So we didn't really get to the version 2 stuff, but the version 2 stuff seems not that bad, right? It's like you just have like more times, with 8 bytes, and then like the real bigger problem is this like wet 0 west shit. So this says we did kind of learn this string a little bit, right? This says we are usually at east wet time zone, offset 0. Then we have west time zone with confusingly not another offset. I thought there was supposed to be another number here for its UTC offset that applies on March 5th at 1 a.m. and October or November. October 5th? No. March week 5, day 0. October week 5, day 0. So we're not parsing this stuff, so there's likely some cases that we're getting it wrong. But my time zone file is not one of those, right? Presumably, most sane people, like, based off what they were saying, it felt kind of like, the, how do I say this? It felt kind of like the string stuff was kind of like legacy behavior, and that like any sane time zone info is just going to have the values we care about. So we're probably fine. We are not looking at this standard wall indicator thing at all. I do think we need to take a slightly closer look at that, right? So we found out that they have the right amount of, like, we found out how many there should be, but we never really figured out what they're for. Whether transition times associated with local time types were specified in standard or wall clock time. Oh. So this is... Oh, so we are assuming here that these are all in UTC time. Or what is standard time versus wall clock time here? UT local, we're assuming UT for now, which is like kind of wrong. Right here. This assumes UT, I think. Right? Because we need to apply the UT offset if this is specified in local time. However, I don't understand standard versus wall time. What does this mean? Oh. So standard time they're using to refer to non-daylight savings time. So your transition time might be specified relative to the time before you switch or the time after you switch, depending on if you're in standard time or not. Yeah. So we're supposed to check this. Check stood for if the transition time is in new or old time, right? So like if is standard and we are is daylight savings, then use standard time, and then like if not is stern and we are is desk, then use our time. You know what I mean? And then is UT is for like if this is true, then we can take the Unix timestamp directly. But if this is false, we have to adjust first, right? But then like we need to like apply UT offs to the Unix epoch to check. And then it's even more confusing because this is per zone information, right? And we want to go through times, but each time could be flip-flopping between zones that are defined in different units, right? And so you kind of actually have to do a binary search. I was going to say, yeah, your binary search has to basically like make these adjustments, right? So in here, we're supposed to be like apply is standard and is UT, right? I guess is what we're supposed to do here. And I was going to say that you could actually end up with lists that are sorted incorrectly because of this, but you should never have a double flip-flop within like one daylight savings time. So if you do that, like kind of go fuck yourself. Yeah, so maybe this isn't actually that bad. Right? So we check like here, the context is actually going to be like search context. It's going to be like val is an I64. Then we have like parent is TZ info or something. And then this guy takes in a search context of val is time and parent is this or self. Right? And then in here, we look at item zone. We look at this is search context now. We have like context dot parent zones at item zone. And we want to look at like if zone info is standard. If info is UT. If this is not UT, we have like comp time. Compare time is item time, right? Easy. No. The value. If zone is UT, then we apply comp time plus equals zone info UT offset. Beautiful. So that kind of handles that. And then we have if zone info this is standard. This is confusing. We have is STD and is DST are like mean two completely different things but look very similar. That's funny. So if we are is in daylight savings time and I guess if the zone info is not in UTC time, that's the only time this matters, right? So it's kind of like in here. If zone info is in standard time, then you have to like somehow find the standard time associated with this DST. You know what I mean? Which is just like, I don't know how to handle this. So I'm just gonna do this. Because I don't know what to do about this at all. But then we should be able to compare comp time with item time. And we fucking hit that case. Fucking shoot me. I guess by default, we actually probably want to define is UT to true. Because we want to assume that this is in UTC time unless we know otherwise. Okay, and then can we look at that unreachable? So, can we look at the zone? So here we are seeing that this is defined in local time. Can we print out what this fucking time is? I'm a little confused. So this is in 1990. In my time zone at 1 a.m. No, see, this is confusing again, right? Because we're seeing this is not universal time. So he's saying, like, I am not universal time. Right? Which means that, like, the definition should be in local time, but this epoch thing is saying that it's defined in universal time. Right? Daylight savings always occurs at 1 in the morning, and this timestamp is 1 in the morning local time. So, like, what I must not understand what this means. Right? We must not get it. A series of 1 octet values indicating where the transition occurs associated with the local time types were specified as UT or local time. Each value must be 0, 1. 1 indicates universal time, and the corresponding wall must also be set to 1. A value of 0 indicates local time. The number of values specified by the is to current field in the header. If this is 0, all transition times associated with local time types are assumed to be specified in local times. So we are seeing is UT, we take byte and check if it's not equal to 0. So 0 indicates local time. Yeah, okay, so we're seeing local time here. And then if we see 0, Standard time or wall time? All transition times associated with local time types are specified as the wall time. Maybe that's where I'm confused, is that we have no time types associated with local time. Time zone designation. A series of octets constituting an array of null terminated time zone designation strings. The total number of octets is specified at the character count field, blah blah. They may overlap. The character encoding the time zone is not specified. However, see section 4 of this document. No, wait, this is the string stuff. That's not what I'm looking for. I'm looking for transition times. Each value is stored as a transition time at which the rules for computing local time change. The number of time values is specified this. This should be blah blah blah. Then we have transition types, specifying the type of the local time of the blah blah blah. Huh. I feel like I don't understand. This does not make sense to me, right? Because what we're seeing is that these values, these numbers are very clearly UTC time to me. Daylight savings always happens in the fucking morning. Which is inconsistent with what we're seeing here. Can we read this again? A given pair of standard wall UT local indicators is used to designate whether the corresponding transition time was specified as UT standard time or wall clock time. There are only 3 combinations. To designate whether the corresponding transition time was specified as UT. There is 1 UT standard. Wait, what is the. Okay, yeah. UT standard or wall. So UT indicates is 1. This feels bugged to me. Right? So unless we have this in the wrong order? No, this is this, then this. So we're seeing 0, 0, right? We're seeing standard time. But again, it just doesn't make sense. Okay, can we not do this for a second? And can we just print all the zone info? Because I'm obviously not understanding something. So can we go, like, look at each zone that we get? Zone. Like, okay. So we have double true, double true. Then we have the ones that are going to standard time. So anything with transition time 2 is hitting the case where it's not in universal time, but it's in standard time instead. Okay. Then we have false true, which it said shouldn't ever happen, right? It says that you should never see. You shouldn't. If we see universal time, this thing must also be set to 1. So this feels like we're not parsing correctly. Kind of feels that way. Can we, okay, so anything that has a zone, can we compare the difference between zones 1 and 2? Like, maybe we just got unlucky with this. So can we also print the transition times, but with their zone info? Okay, so like, let's just check So this guy with zone 1 is 3 a.m. This guy with zone 2 is 1 a.m. in local time. So I don't understand. I don't understand. It feels to me like we're parsing this wrong. Can we look at, is UT here? Like, are these valid? Is UT is equal to 0? Or is UT is equal to 1? And then we should do the same thing here with is STD. Okay. So these are invalid. So we must not have parsed right. Right? That's what this is starting to look like? Is it that in version 2? Okay. So we get transition types, time count, leap second records is leap count times time size plus 4. So we have 0 leaps. Standard wall, UT local. Are we reading this right? So we have time count, we read either 2. I guess maybe time size. Maybe I misunderstood that like time size should be 8 on version 2. No, because we have the version 1 header and data block at the beginning. Something seems wrong. Can we hex dump this thing and try to find our zeros and ones in here? Right? Like we should be able to find our 5. So we have our like car count is here. So before that we should have is UT and is DST. So these are here, right? Which means that like, yeah, we're like very much seeing values in here that aren't 0 and 1 directly before, right? That's what this looks like. So like, what the fuck? Maybe we have leap second stuff in here that we're not. Oh wait, hold on. Am I getting confused by the ordering? Oh, sorry. Car count is before stood count. Sorry. So it should be here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So what we should be seeing is 4, 0. We should be seeing 4 sets of double 0 and a set of double 1, which is not what we're seeing, by the way. Oh, because we're just parsing this in the wrong fucking order, right? False, 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 false. There we go, baby. Okay, so now at least they're valid, but they are still double false, which does not line up with my understanding of this at all. Right? Like, did I lose the actual thing? So if we are double false, We are double false. We are in local time. Local wall time. Time corresponding to the transition time specifies local time for timestamp starting at the given transition time, but not including to the next transition time. Local timestamp for timestamps before this is specified by time type 0. Local time for timestamps on or after the last transition is this thing. A given pair of standard wall and UT local indicators. These designate whether the corresponding transition was specified as universal time, standard time, or wall clock time. There are only 3 combinations. So we are in wall time for most of these. The information can be useful if the transition times in a TCVO file need to be transformed into transitions appropriate for another time zone. This is only used when you're using a TZ string to modify a different guy. Aha! Aha! So we don't use this at all. I was wrong. Fuck these things. Yeah, we do not need them. We do not need them. I completely misunderstood. So this is just val time. There we go. Okay. Well, that took a while to understand. Could have read a little bit more carefully. But we got there. It is 14:29:28 right now, and our thing says 14:29:28. I think that's a win for the day. I think that is a freaking win. So, let's call it there. I think that's all I wanted to accomplish today. Thanks for watching, guys. If you like what you saw, we stream most days. We aim for 12:30 to 4 Pacific time. It is 2:30 now because I didn't do the happy hour segment, which we do sometimes, which is stuff that doesn't go on YouTube. So like maybe we're doing some research for this type of thing, or maybe we're doing some some cleanup that isn't really feature development, something that isn't really like titleable, thumbnailable. On days where we do that like 12:30 to 2 ish. And then the VODs for that go up on Patreon, YouTube members, or in Twitch VODs. And if you pay in the appropriate spot, you get access to the extra VODs. And also the knowledge that you're helping the stream continue, because one day I will run out of money because I'm making around 1/10 of what I made as being a real software dev right now, right? So this is not sustainable, but I like doing it, so I will do it till I run out of cash. And so every dollar I make extends this by some amount. But anyways, that's all the plugging. We should be back tomorrow with taskbar implementation. Now that we finally figured out this date stuff. It's not as bad as I thought it was going to be. I mean, it's like not great. And we're skipping a lot of the hard stuff. But like, this part's fine. Surely this is good enough. Surely this will never come back to bite me. So, happy with that. Thanks for watching, guys. YouTube, peace out, and Twitch, let's find someone to raid.